Alright, let's think about regression with Excel and do an example of how we want to do that. The problem that I'm using is the problem from the Old Faithful data, the problem at the end of the PowerPoint. Here's the data. You see it on the left, and the first thing we want to do is to make a graph of that data and see what it looks like so that we can determine which formula we need to use to we want to do a scatter plot. Alright, here's my scatter plot. Let's make the graph smaller so that it's not in the way. And we'll bring it over here. Whoops. We'll bring it over here and put it out of the way. So looking at that graph, well, maybe it's linear, but no, these points are in the way. Maybe quadratic would be a good description of this data. So if we want to use a quadratic formula, we will need to use the equation y equals ax squared plus bx plus c, and we'll need to plug the x's and y's for each of these points into that equation. So let's look at those equations. The equation that we want to use, once again, is quadratic. Ax squared plus bx plus c equals y. And where did I get this for? Well, I plugged 2 into x squared, or negative 2. I plugged negative 2 into x. I plugged nothing into c, and I plugged the y value into 8. And I did that for each of these points on the graph. Now what I need to do is to make a matrix equation of these of this system of equations, and so I'll do that in Excel right here. One really important thing about using Excel is that I need to I need to show the label, and I need to show any matrices that I use boxed so that I can see what I have. So I'm going to, first thing I'm going to do is write the equation ax squared plus bx plus c. I need to put these pluses at the end of a cell, not at the beginning, or Excel will think that I'm doing something else. That tells Excel to do something else. It's formulated. Okay, so here's the equation. Now, this is going to be my A matrix, the coefficients matrix, and this will be my constants matrix. My coefficients of A, the numbers that are multiplied by A, in each case were x squared. So I'm going to, rather than square this in my head and type it in, I'm going to let Excel do the work for me. If I type equals and then click on the x and tell it to square x, Excel will do that calculation, and then I can just pull down to get the rest of them. In this case, every number that's multiplied by b is just equal to x. So equal to x, and we'll pull down. In each case, c is multiplied by 1. So I'll enter a 1 and pull down. And the y values are form the constants matrix. So I'll just pull down the y values. Okay, now I need to label my matrix and box it. I'm going to go right here and box it. And box it. And I forgot to put in a column for my label, so let me do that right now. So I'm going to call this one matrix A and this one matrix B. And just so that my A is closer to my matrix and my B is closer to my matrix, I'm going to right justify them. You don't have to do that. Okay, so here is my coefficients matrix. It's the matrix formed by taking the coefficients of each of these equations. Here is my constants matrix. And there, they come from the y values. Okay, so here we have our matrix. In general, we're at this step right here. The A matrix is this matrix. X is A, B, C. And the B matrix is here. In order to do a regression, because this matrix isn't square, I have to square it up. And the way I square it up is by multiplying by the transpose on both sides of the equation. So I'll need to find the transpose of A. I'll use Excel to do that. And then I'll multiply the transpose on both sides of the equation. When I multiply A times A transpose, I'll get a new matrix. That is a square matrix, and I'm going to call that matrix C. When I multiply A transpose times B, I will also get a new matrix. That matrix I'm going to call D. Now, this equation, this matrix equation, has a square coefficients matrix. Because this matrix is square, I can find its inverse and multiply the inverse of C on both sides of the equation. When I multiply C inverse times C, of course I get the identity matrix, and the identity times X is just X, so on the left side of the equation I have X, and on the right side I have my answer. So let's go ahead and find A transpose. To find A transpose, I'm going to label it, whoops. I need to know the size of A. A is 5 by 3, so its transpose would be 3 by 5. So I need to highlight a 3, 2, 3, 4, 5 by 5 area and type equals transpose. Highlight A, parenthesis, and then either Control or Command Shift Enter. And before I do anything else, I'm going to box it. All right, I have A transpose. What do I need to do with A transpose? Let's multiply it on both sides of the equation. So I need to multiply A transpose times A and A transpose times B. A trans times A, we said we would call C. And when I multiply a 3 by 5 matrix times a 5 by 3 matrix, the result will be what size? Yes, it will be 3 by 3, which is a square matrix. So equals mmult A trans, comma, A, parenthesis, Control or Command Shift Enter, and there is my new matrix C. Let's box it. I also need to multiply A trans times B, and we're going to call that one D. It will be a 3 by 1 because I'm multiplying 3 by 5 times 5 by 1 equals mmult A trans times B, parenthesis, Control or Command Shift Enter, and let's box it. Okay, so now I have C and D. In order to solve this equation, I need to find C inverse and multiply it on both sides of the equation. Oops. So C inverse, is going to be the same size as C, which is 3 by 3. So let's highlight a 3 by 3 area equals minverse C, parenthesis, Control or Command Shift Enter, and let's box it. Now, I can multiply C inverse times C using mmult, but of course I will get the identity matrix with 1s on the diagonal and 0s everywhere else. I know what that's going to be, so I'm not actually going to multiply this in Excel, but I do need to multiply C inverse times D. Let's do that right here. Of course, a 3 by 3 multiplied by a 3 by 1 will give me a 3 by 1. Oops, I spelled it wrong. mmult. And I want to multiply C inverse times D, parenthesis, Control or Command Shift Enter, and box it. Whoa. Okay, so my equation now is x equals this matrix. Well, x is A, B, C. So basically, A equals 1.298, B equals 0.465, and C equals 4.759. Okay, and so there we have it. What does my answer mean? Well, of course, what I have found are the A, B, and C of a quadratic formula that best fits this data. It is the parabola that is closest to all of the points in the data. And we don't have a very big data set, but this equation best approximates it. So what I want to do is I want to look at, well, how well does it approximate it? So I'm going to make an extra y column here and see how my points compare, the points that I have compare with the regression points. I'm going to type in 1.298x squared so that I know what I'm doing. 0.465x plus 4.759. That's the equation that I'm going to use to calculate these new y values. So equals 1.298 times, I have to put the times in, x squared plus, I need 0.465 times x plus 4.759, and enter. Alrighty, let's pull down. And now let's revise our graph a little bit. Let's pull our graph over here where we can see it. And just graph all of those points together. So I want a scatter plot with all of them. Okay, well look, these points are fitting pretty closely, and this one is as close as it can get to both of those. So this equation is the parabola going through these red points that gets closest to the points which I originally had. Okay,